Welcome to a design tutorial about testing and evaluating. This is a really important part of the design cycle and something that has to happen all the time. It's vital to the success of any product, and it's something that's ongoing. We'll take a look at the design cycle in that regard and how it relates to other things. And often it's an area that we particularly in MYP and DP, we skip over this in an academic sense, and we actually only apply a certain amount of time to it, and yet it's worth exactly the same amount as anything else. And if we look at the real world, we see people invest a lot of money and technology in testing, because if they don't, they'll have all sorts of problems. We'll just take a quick look at weather questions and surveys and what is a well-designed test, and how do we acquire valuable knowledge that can help impact our programs. Often people just throw out questionnaires and they're not really helpful in any way. So we have to look for authentic ways of testing, and testing in its location, testing in place, because products recalls cost companies a lot of money every year, and a lot of companies go bust because they don't test properly, and companies need to test against international standards and against the market in which they are going to be operating. This is a really relevant topic because thousands of people work in testing every day, and if they don't, then the products don't come out satisfactorily. So you've all seen examples in IKEA. When you walk through the IKEA shop, you'll see drawers coming in and out, you'll see chairs being pushed, okay, and you've all heard stories on the news about airbags being recalled, brakes being recalled, people even dying because the brakes froze and the company never tested the brakes under freezing conditions. So as I said, thousands of people work in testing every day, and it's really important because these tests can save people's lives. They can save kids' lives with little toys and parts of things that can break off, etc. Tests are a vital part of the design process. So we'll take just a quick look at the concepts behind this. We really want to be suggesting realistic recommendations from our tests. We want to have a variety of them. We want to test everything about a product, its joints, its value to the client. We want to test everything, okay? We want to try and indicate areas of weakness where we can improve on, so that we can fix the product and make it better, okay? And we really need to check that the product is fit for purpose, because we don't want to be designing products that are not there. And if we want to test for greenness or something, or if we want to be empathetic towards the environment, then we really need to be testing that in some way. So in MYP, for instance, we really need to be concerned, and this mirrors real life as well. We really need to be worried about designing tests, okay? We can't just think of, we're going to do this test. We actually need to design the test, and we need to put thought into the design of the test, and then we need to document how we design that test. And in that way, we can reach the top criteria, because then we can carry out the tests and we can make them authentic. We need to, this will help us get detail into the testing method. It will help us focus on the design specification, and by getting this in there, we can really then assess how we could improve the product and make realistic recommendations. And the last thing we might really want to be focused on is we need to explain the impact on society and the wider environment, in the impact on the solution on the client though, particularly as well. So the criteria are pretty clear about this. We must design detailed and relevant testing methods, okay, that generate data. This is not just a survey saying, do you like it or do you not like it, okay? We need to design this. We need to put thought into this. So we need to then critically evaluate the success of the solution, okay? And if you're going to be critical, you need to compare it with other things and say, all right, well, is my test valid? This is how we get critical nature and critical thinking into this. We need to be really worried about it being authentic. Okay, we need to explain how the solution can be improved, and we can do that when we get authentic, and when we get critical, this will naturally flow into an explanation for improvement. And then we need to be thinking about this impact. So they're the criteria, okay, and we can see from that we need to spend some time there, and we need to give this some thought. And if we want to think about it a little bit more, if we dig into the design guide for MYP a little bit more, we've got these expert appraisals, field test performances, and we can't just make statements about these, we have to justify them. So you think about what is a field test, okay? Is it durability, robustness, suitability? A field test is when you're seeing the drawer go in and out. But actually that's not a field test in IKEA. That's a factory test. And a field test is when a person pushes that drawer in and out, because a field test is a real test. Okay, and a performance test is more like that IKEA thing where you see the thing going in and out, in and out. That might tell you that the drawer can go in and out 1,000 times without it breaking. But a field test is even worse, because a person doesn't push it in and out in a mechanical manner. A person pushes it and twists it and folds it and puts a lot more pressure on things. And this is why furniture that, for instance, that is designed for schools has got to be a lot tougher than furniture that you might see in the house. So field tests are very, very important. And we can't just glibly say, oh yeah, I'm going to run a field test. Okay, we really need to be thinking about this. We can get someone to use the product, and then we can observe them. Don't just ask them questions. We observe them, critically observe them, and say, how are they using this product? How are they using that bat? How are they pushing that drawer in and out? How are they, how are they putting that pen in that pencil holder? How is that photograph going to slide in and out? Can the person slide it in and out? These are the questions that we need to ask, but they're also the questions that we need to observe, and then we need to document that over a number of people and or a number of occasions. So both the MYP and the DP, they are similar design cycles, and we can go and look at any design cycle in the world and they'll all give us similar answers. The evaluation stage is a very, very important stage, but these arrows that are going back and forth, they're very important, and we need comments, evaluative statements within our evaluation stage, within criterion D, if you like, that link back to analysis and say, hey, we found this out, and now we're going to do this test from our investigation, or in our design we thought this, but now we have to go back and redesign this, in that criteria. So this is what happens, and this is just a reflection of what happens in the real world. So I'd just like to reiterate that testing is something that does happen every day. There are thousands of people that are working in factories that are just testing, okay? And testing must be done against international standards. In reality, if we don't test against the market that we're going to put our product into, then it won't be successful. I'd like to show you some real products now being tested, and these in a factory, and they happen to be in Shenzhen. This is a mirror on one side and a little makeup holder on the other side, actually, and it's meant to hold sunscreen. And so this product actually didn't get to market because when it was tested, it was found that the sunscreen constantly just washed away everywhere, and they needed to actually change the mix of the sunscreen to make it less viscous, so it didn't come out all the time. So testing's really important. Here we have a man who's got the plans, the specifications, the actual, this is how big this part should be, and he's physically measuring all of the parts of the of this product, which happens to be a case for a metal detector, and so the case has to go together. And we've spoken to you in the past about tolerances. Tolerances are very, very important here because this case has to fit around something, and if the tolerances have been incorrect, then the screws won't, or the bolts, then it won't go. The fastening mechanism won't clip together, and or there won't be space inside. So this guy here is measuring everything with the vernier calipers and checking that it's all been done to the specifications. Here is a press machine that is just sitting there waiting to be used to put pressure on things to see how much they will be able to take before they will break, because you can't produce something that's not going to last very long. Another machine here, which I think this one's testing the scratch proof of this glass, and also press again. People spend a lot of time and effort designing machines to test. So this is actually a button pusher. You can see the little object in here. It's a little electronic device, and this thing's going to come down. It's going to press the button. So it's going to press that button thousands of times, and then they're going to be able to assess whether it's actually going to last long enough or not. Because nobody's going to sit there and test this that long, but a machine can test it, and they can let it go overnight, and they can have the frequency and ratios, etc. Okay, so there's more examples of machines that have been designed specifically to test. So this machine actually is going up and down, and it's scraping. So it's seeing how long it will last before it wears out. There's another one there. You can see in the bottom here, this is an actual tool, and it's being tested, in its place. This is a cam arrangement here. So this lever, it's got a pivot point. This is like a big hammer, and it's banging down the end here of this like it's like a cold chisel, okay? And so this machine is replicating a hammer beating on the end of an object that's designed to be hit by a hammer. But if you design something to be hit by a hammer and it only lasts 10 hits, then you're going to be out of business pretty soon. This one's a very interesting one. This is testing spirit levels, okay, so laser levels. So you're going to sell a laser level to someone, you need to be able to guarantee that it is level when it gets there. So look at this, the technology here. There's actually a smartphone up on there. Now they've made this massive long thing here, this jig, to put things up, and then they've leveled it out, and then they physically, and then they'll start putting their machines on there, the actual devices on there, and check whether it's level or not. And I spoke before about tolerances. There's, how many parts here? 1, 2, 3, 4, 5 parts clicking all together. If the tolerances are wrong, they won't click together. So this is all about testing and making it work. Before you make 1 million of these little red parts, you need to check that they're going to fit in. Testing will always involve a process, and there will be plans, and there will be maps out for how this is going to be tested and who's going to test what at different stages. Companies need to provide these sort of plans to their workers so that they can get this going. So testing is very, very important. So next, let's just take a look at how students test things. We'll look at a few different examples because we don't want to be looking at just one grade level. But here's a real testing implement. Okay, so yes, we want to check for temperature, so we're going to heat this up and then we're going to check the temperature and we're going to see how long that goes. So testing, as I said, it needs to be real. We need to get real data at different times of the day. This is why that car, the brakes failed, because they didn't test it at the right temperature at different times of day. We need to test in place. We need to get people to use it. We need to take it home or to the location where it's going to be. We need to actually then just check, does it do its function that it was meant to do? What improvements could be made? Get other people to help us and give us feedback. So there's an example of some testing, and then running it against the specifications as well, making comments, trying to figure out who's going to use it, what the target market and the target audience might think about it, what different people will say. We need to get genuine feedback about our products, okay, and do practical testing, and we'll be able to make graphs and things like that, and this will help us to really assess what people are thinking about it and how it's going, etc. So the more data that you can collect, the better. But as I said, don't just rely on surveys. We need to think about things like, fire hazards. We need to think about things like entrapment with fingers or little bits falling off. There's lots of rules in the world, and these rules are all come out by the country's standards or international standards, and we need to be looking up those standards and seeing, okay, well, what can I test to prove that I've met this standard? Because if you're going to sell a product in a country, then someone's going to ask you, have you met this standard? And you'll have to have that ticked off. So we need to test in place. We need to do lots of different things to actually see how it's going, and be systematic about this. Go through the specifications and see whether we've actually met them or not. So we don't want to necessarily see walls of text, but we do want to see the specifications. We want to see the tests being run. We want to see the results and the success or otherwise. We want to see pictures. We want to see sketches of changes and diagrams to explain. We want to see graphs of the people we've met. We want to see pictures of people using our products, etc. Other formats might include a format like this. This one's really about a green design solution. So we've got, here are the specifications. We're looking at them. We're looking at the strengths of the design, the criteria, what's going to be improved or weaknesses. So we need to be looking at these things. We need to be sketching. We need to be thinking about real and legitimate improvements that can be made to our product. And then we need to suggest them and show how we could actually do this. So this is a really good example because it's got some great sketches and improvements that can be shown that this is what we'll try to do. In the earlier years of the MYP, we'll probably give you a sheet and we'll ask you to do the testing and the specifications like this. So you've got here, see, they've identified field trial, expert appraisal. So the pressure's not on so much here, but we need to keep these concepts in mind. Okay, and we'll give you sheets that will help you structure things, analyze the tests, think about things in a systematic way, product impact, design improvements that we can make, etc., and then reflect on them. So although this has been a long video, I hope we've just given you a really good understanding of the fact that testing is a really important part of the design process, and that should be given equal attention, just as to investigating or designing in the first place, because if we don't give it equal attention, we won't have products that are real. Thank you for listening.